Hello and welcome to another mathematics video. Recently, a friend of mine asked me to help him with a mathematics problem, and the problem was if the area of P is equal to 1, find the areas of Q, R and S. And of course you'll see that P is this triangle here, that is triangle Q, that is triangle R, and this is region S. And they're all components of a larger square of side 2B. So as you can see, I've drawn on all the dimensions here. Let me just click on that. So we've got a diagonal that joins this point of the square to the other point on the opposite side of the square, and this diagonal joins the left hand corner to the midpoint of the upper side of the square, so that this distance here, which I'm outlining with my cursor, is B. So this is length B, and this length obviously is B as well, and this side is 2B. Now, I've also labelled this height of this triangle as H because, as you may recall, and I'll just write this on the, I'll just write this down. Let me get where I want to be. Right, okay, so half the base, that's this base B, times the height is equal to the area of that triangle. We'll call it the area of P. Now, how does this help us? We know, first of all, that a half B times H equals 1. So we know what, already, because we're given this in the question, what the area of this triangle is. So that's done for us, if you like. But what we have to find is the area of Q, the area of R, and the area of S. Okay, so how do we do that? Let's have a look at triangle Q. How do we work out what the area of Q actually is if we don't know what the actual dimensions of B and H are? Well, you'll note this is diagonal, and I've redrawn the square over here. This is the whole square, and this is the diagonal that joins the left hand, or the upper left hand corner, to the lower right hand corner. Now this is the height of this triangle here. This is the height. So I've redrawn it on here without drawing this diagonal. So as you can see, if that is height H there, joining this upper side to the diagonal, then this side is also H. This is also of length H, just by symmetry, because this whole thing is a square. So that should hopefully now be quite obvious to you. So this helps us because we can then go ahead and work out the area of all of this triangle. Now that we know what the height of this triangle is. Well, what we'll do is we'll just write down what the area of this triangle is then. So the area of Q is again equal to a half the base times the height. But the base of this triangle is 2B. 2B. So it's a half of 2B times H, right? A half of 2B times H. And so that comes out to be equal to B times H. But that's not a numerical value. How do we work out what BH is? We still don't know what B is, and we still don't know what H is. Well, if you notice, we've got a half B times H equal to 1 up here. That is the area of the first triangle here, right? The area of the first triangle. So what we can see, and in fact, I'll go on to another page now. So we'll label this equation as 1, and we'll label this as equation 2. So if we go on to another page, we've got a half base times height equals 1. And the area of Q is equal to a half times 2B times H, which is B times H. Well, I did say that I was going to label these two equations as equation 1 and 2. So we'll redraw this a little bit further over here. So we've got half base times height equals 1. And we'll call that equation 1. And this is equation 2. And really, I'm writing it like this to save space. So I hope you can follow what I'm doing. Now, from 1, let's go to the thicker line for writing. From equation 1, BH equals 2. You multiply both sides of equation 1 by 2, and we'll just do that. We multiply both sides of equation 1 by 2. We find that BH equals 2. And I'll write this down, and since equation 2 tells us that the area of Q is equal to B times H, then the area of Q has to be equal to 2. So now we've got our second area. The area of Q, and I'll write that a little more clearly because it hasn't come out quite as well as I'd wanted it to. We'll just emphasize that as area of Q is equal to 2, right? So we found our second triangular area. The first one being 1, the area of Q being 2. Now, what I'm going to do is I'm going to go back to this these diagrams, and I'm going to cut this diagram here and paste it on a new page. So add to new page. Right, okay. How do we work out what the area of R is? A sub R, if you like. How do we work out what the area of R is? Because clearly this height is not the same as this height, or I should say this height here. We'll just draw that in red. We'll draw this in as, let me just click on that, right? This area is due to H. Right, okay, so H2 is clearly not the same as that height. So what do we do? Well, you'll notice that the whole length of that side of the square is 2b. So to find this height, you work out what 2b minus h is. So h2 equals 2b minus h, right? So we just bear that in mind for a moment. We know that the area of R is equal to a half base times height. Right. In actual fact, the base is 2b, isn't it? 2b times h2. So the area of this triangle is a half of 2b times h2, which we've got here. So A of R is equal to BH2. Not the same as the BH we had before, BH2 this time. So how does that help us? Well, the area of R is equal to B, and we substitute in this H2 component here, which is 2B minus H. Now, the area of R is equal to B times 2B minus H, which when you multiply it out becomes 2B squared minus BH. But we know that BH is equal to 2. Let's just go back to where we had that. BH, I'll just see if I can find the page. Where are we? Yeah, so the area of Q, which is BH, is equal to 2. So the area of R is equal to 2b squared minus 2. And I'm actually just going to leave it like that rather than factorising out the 2, because it should hopefully work out a little bit easier. It may, well, anyway, we'll see how we go with it. So how does this help us work out an actual numerical value for area R? Well, there's something you may notice. This base, and we'll highlight it again in green, this base along here is twice this base up here. And these are similar triangles. These are similar triangles because we've got two diagonals that intersect each other. So that triangle has all the same angles as this triangle. And I'll explain what I mean by that. We've got this angle here, we'll call it X. And it's basically, if I can draw this on, it's basically a Z angle. So that angle is X there as well. And this angle, which is Y, is exactly the same as this angle down here, which is Y. And this angle, which we'll call theta, so I'm running out of letters to use, it's exactly the same as theta there. So these are similar triangles. I'll write that down for you, similar triangles. Right? So this length is twice as big as this length. So we'll write this down because we'll just call it 2b is twice, whoops, let me just write that a little more neatly, twice the length of b, then the area of, well, we'll just we'll write it down as AR. Then the area of R is equal to 4 times that of the area of P. Now, how do I get that? How do I work out that the area of triangle R is 4 times this area? Well, the reason is, you may have come across this in GCSE mathematics. Let's just go on to another page. Basically, if you've got a length that, we'll call it L, and you multiply it by 2 so that you've got 2L. So 2L is twice as big as L. Then the area is like, well, the area of whatever shape you've got can be measured in terms of L squared. So if you square that, and you also square the corresponding enlargement from this original shape, then you've got 2L all squared. So that is the same as L squared, translating to an area that is 4L squared. If we had had L, the original length L, and let's suppose we multiplied that length by 5 so that we have another length that's 5 times bigger than L, then the area would have been, well, the original area would again have been L squared, but the new area would have been 25 times the original area, L squared. So what you do is you square this quantity here. There we are. You square that quantity. And just to emphasize that again, if you tripled, but this is just a quick aside, if you tripled an original length, so if you had an original length and you blew it up three times its original size, then the original area would be in terms of L squared, but the new area would be 9 times the original area, L squared. So that is how we know that, and let me see if I can go back to the original page, wherever it is. Yeah, so here we are. Because 2B is twice the length of B, then the new area of triangle R is 2 squared. Or if you like, 4 times as big as triangle P. And so we've now got 3 areas. Well, the next bit requires a little bit of algebra because we have to find out the length of B. So we need to use this formula here, given that we now know that AR is equal to 4. So let's just go on to a new page. So we'll write this down. Since, what did I call it? Let me go back to that. So since AR, let me see if we can, no, we can't cut and paste that at the moment. Let's just go back to the page we're on. So we've got AR equals 2B squared minus 2. So AR is equal to 2B squared minus 2, right? And we know that, well, we've just worked out that AR is equal to 4. So, this means that if AR is equal to 2B squared minus 2 and AR is equal to 4, then 2B squared minus 2 is equal to 4, isn't it? So, solving for B, we get 2B squared equals 4 plus 2, right? You add 2 to both sides of that above equation, right? So that's what we've just done. And adding 2 to the left-hand side gets rid of that minus 2. So this implies that 2b squared equals 6. And if you divide both sides by 2, you get, let me find my pointer, b squared equals 3. So we've just divided both sides of this equation by 2 to get b squared equals 3 here. Where's my pointer? There we are. So I'll just get rid of that and make it look a little bit neater. So we can infer from this that b is equal to the square root of 3. So it's actually, since we're working in centimetres, actually, I don't think I stated that right at the beginning. But I mean, it can be in any units you like, this particular question. But I think the original question that my friend proposed to me was in centimetres, so this would be 3 centimetres, but we'll just put 3 units. 3 units in length. Right? So how does that help us work out the area of S? Well, because we now know b is root 3. So let me just go to this. Yeah, here we are. So we'll just cut and paste this. So it's a bit easier. So let's just add to new page. Right, let's just erase. Ooh, it's not erasing. Never mind. We'll just leave it as it is. Right, okay. So we've got a square here, and we know that this is the side of the square, right? This is also similarly 2b. So the side of the actual length of the side of each square is, well, we'll just delete that and we'll insert the root 3 because we've worked out what b is. So root 3. So the area of the whole square is 2 root 3 times 2 root 3. That leaves us with, well, we've got the 2 times the 2, which is a 4, and the square root 3 times the square root of 3, which just becomes 3, and the area is 12 square units. 12 units squared, right? So we know that the area of, let me just draw this in. Right, okay. So we've worked out, I'll just redraw these in green. So we've got the area of P, area of Q, and the area of R, and the area of S. So the area of S is simply, whoops, losing my pointer there, 12 minus 1 minus 2 minus 4, right? Because we've worked out the areas of all these 3 triangles. And that leaves the area of S being equal to, well, that just becomes 12 minus 7. So the area of S is equal to 5 units squared, right? So I'll just conclude. Oops, let's just get a new page. So the areas, whoops, let me just delete that. So the areas are as follows. I could write them as a ratio actually, which would be 1 to 2 to 4 to 5 units squared, right? Or you could just write it as the area of P equals 1, the area of Q equals 2, the area of R equals 4, and the area of S equals 5, basically, in terms of square units. So, yeah, I hope that you've enjoyed that and it's helped you. And so until next time, I'll bid you farewell for now and look forward to seeing you again. So, yeah, thank you very much for watching and goodbye.